Hi, in today's video we're going to be focusing on functions. Functions are the building blocks of mathematics. Everything is represented in functions in real life, from trends to growth to finances. Everything is presented as functions. Functions actually map out patterns of data, how data grows, how information grows, where things were, and everything else all depends on functions. In this video, we're going to focus on linear functions. To start with, linear functions are also called straight line functions. Just the name explains itself, they are straight lines. So assume you have a Cartesian plane. This is your x, this is your y intercept, this is your origin. So a function can be this way. It's a straight line function. Or it can be this way. Or it can be this way. Or it can be this way. Whichever way you have seen here, a function can exist in that. Now let's explain how it works. So I've written 4 lines here. Now I have to explain how functions work. So functions that are straight line are defined in the form f of x is equal to mx plus c. C is the point in which the line will cut the y-intercept, usually this line or this line. The y-intercept is this line, so any point that the function will cut the y-intercept is called a c in this formula. Then m is the gradient of the function. M is the gradient, and then c is y-intercept. What do I mean by the gradient? The gradient explains the slope. Gradient is equal to the slope. What is the slope? For the fact that this line goes like this, we say it is sloping upwards. Starting from your left hand side going up, we say it is sloping upwards. So it has a positive slope. The fact that this line is built like this, we say it is sloping downwards. So its gradient is going to be negative. So any line that is higher on the left hand side and then lower on the right hand side, it's going to have a negative gradient. Any line that is lower on the left hand side and higher as it goes to the right, it has a gradient of positive. It doesn't matter what the value is, but it's going to be a positive gradient. That means m is going to be greater than 0. Any line that is parallel to the x-intercept or to the x-axis has a gradient of 0. This line here, it has a gradient of 0. So its equation is just going to look like this. It's just going to look like this. So let me start with the first line. So I said any line that looks like this or whatever the case may be, but is lower on the left hand side is a gradient of positive. Any line that looks like this or whatever the case may be is lower on the right hand side but higher on the left has a gradient of negative. So m is going to be less than 0. And then any line that is straight like this as a gradient is equal to 0. So its equation can look something like this. Y is equal to c. YC is the y-intercept, is the point in which it cuts the y-intercept because it doesn't have any gradient. So the gradient value is going to be 0. So for these equations, So for these lines that have the gradient looking like greater than 0, equation can be something like f of x is equal to whatever the m value is, x plus c, if it casts the y-intercept. Here, less than 0, it can be f of x is equal to whatever the m value is, x plus c. And then the same applies for y m is equal to 0. It's going to look like this. It's going to look like this. Now, what about the case where our equation looks like this? Our line looks like this. So, in this way, our gradient is just equal to the x value. It's a straight line. So, our gradient is 1. So, our equation can look something like this. Whatever the x value is, it's going to be our gradient. In this case, it's going to be 1 because our gradient is 90 degrees, exactly perpendicular to the x-axis. So, if you are given any line, so at this point, we are able to see from the graph or any graph that will be given, especially pertaining linear functions, what the gradient or equation of the graph might look like or what it may be, regardless of its situation. That's it for this video. Thank you so much for watching. Let's go on to the next video in which we expand on this.